Hi everyone, today we are going to continue on with our solving, this time using logarithms to help us solve exponentials. Now we've talked before about being able to move this exponent out front to solve by taking the log of both sides, because what this allows us to do is that x can now move out front. We have log of 7, and then we have log of 20 on the right, and if we divide over log 20 by log 7, we get our final answer. So this is something we've been doing now for a few weeks, right, in solving some of our exponential word problems. And in this case, we would get about 1.539, so basically 1.54 if we round up on this one. Now, here's the thing. Okay, we also have talked, though, now about undoing an exponential base using a log of the same base. So now we kind of have an option 2 here. So if I move all of this out of the way, if we take this piece and kind of move it down, just so we know this is an answer that works for us, we can take log base 7, and that'll undo this 7 here, so we have the x. Well, what we do to the left, we also have to do to the right, so we're going to take log base 7 of 20. And a reminder, whether you're using the change of base, which would be what we already actually have typed in, or if you use, alpha math, to get, we have this log base 7 of 20, or again, log 20 divided by log base 7 with that change of base formula we talked about in previous lessons, we get that same answer, right? So basically, we have more than one option now to potentially solve some of these. In our next example, we can divide over to start the 8. So we can get our isolated function here. We have 10 to the 9 times m power, and then 89 over 8, right? Which, if we take 89 divided by 8, we have about 11.125. Now, similar to what we were talking about before, kind of have two options here. Option 1, if we take the common log of both sides, right, log, and then now the 9m can move out front, and then log here, we have 11.125. Well, a reminder, log of 10 is going to kind of cancel it out, right? Like log is a base 10, so this is actually just going to become 1. So we have 9m equals log of 11.125, and then we're going to divide over this 9 to get m by itself. So log of 11.125 divided by 9, we get a total of about 0.116 on this one. Now, officially, though, from this point up here, okay, again, you could have thought of this as like, okay, I'm going to take just log base 10 of both sides to get this to cancel out, and we would have that 9m equals log base 10 of 11.125, which again is the common log, and then divided by the 9. So again, same idea. We could, though, have typed this in as alpha math, log base 10, and then 11.125, and then divide that by 9. We still are getting the same answer of 0.116, but just another way of looking at it as well. All right, next examples, part C. We have a little bit more we need to isolate first. So this time we need to start off, we're going to subtract over the 7.6 so that we have 8.3 times 5 to the negative 4v power 102 minus 7.6. We get 94.4. And then to get this exponential by itself, we need to divide by the 8.3. So we have 94.4 divided by 8.3. and we get 11.37. And again, we want to make sure we're using lots of decimal places here to make sure we have the most accurate answer. So we have the 11.373. Okay. Now, again, we have options very similar to what we talked about in part A on this one. A couple ways we could solve this. Okay, we can rewrite this again as an exponential, right? If we take log base 5 of the 11.3734, again, use a bunch of decimal places on this, that's going to equal negative 4v. So we would take, again, math alpha math, log base 5 of that previous value, right? Plug that in there. And then we can divide this by the value, the negative 4 that's with the v, to get our final answer of about negative 0.378 if we round to a couple decimal places on that one. Now, again, that's kind of just option 1, okay? Now, officially, what we could have also done is if we are, again, at this point where we had the 5 to the negative 4v equals the 11.37, this all that. Okay, we can go back to what we've been doing, right? Take the common log of both sides. Negative 4v would come out front. We have log 5 equals log of 11 point, again, all the decimal places. And then we can divide over, again, make sure we have this it typed in the calculator correctly so that we have everything in the correct spot, because we want both the negative 4 and the log 5 on the bottom. But we would type this in log of, I'm scroll up to make sure I use a bunch of decimal places, divided by parentheses, because again, I want to make sure that this is all in the denominator, negative 4 times our log of the 5. And we still get that same answer, right? So again, you kind of now have multiple options to get you that final answer of what you prefer. Okay, so again, more than one way now to kind of do the same thing that we have been. Right? There is an example for you to try then, part D, on your own. See what the value of P is. Again, using either method, you don't have to do both. And then one last note about solving before we move on, and we'll talk more about this in the next lesson, but when we are now actually solving the logarithms themselves, right? Notice each of these problems now have a logarithm. We have the same base on both of those sides this time. So when we talk about basic solving, when they have the same base on each side, we are allowed to just set their inner pieces equal to one another to solve. So essentially what happens, it's like these cancel out and we're able to solve, and just in this case, this becomes a linear equation. Subtract this over and we end up with negative 7 equals 3x minus 22. Add the 22 to get 15 equals 3x. X this time is 5. Okay, now, before we circle that as the final answer, we always want to double check with these logarithm problems because we can't take a negative logarithm, right? So we want to make sure if we plug this back in to the original on both sides, that at no point is this going to be taking a negative. So if I plug back in 2 times 5 minus 7, that is 3. So log base 8 of 3, a nice positive number, should work out to actually work out on this problem. If we have a nice positive number. If we look over here and plug 5 into the left-hand side, we get 25 minus 22. That's a positive 3 as well. So again, log base 8 of 3 is going to be okay to take because it's not a negative number. So 5 does indeed work out as our number. Okay. There is one for B for you to try. You are going to solve for x and then double check that when you plug it back in, that it gives you nice, pretty positive answers. All right, thanks everyone for watching. We'll work more definitely with the second part in solving in class as well.